All right, everybody, our next speaker is an engineer here at Lyft. He's got extensive experience building some of the core formative streaming and messaging systems here at Lyft, and was also the technical lead of Bing Search in the past days. Please welcome Hafiz Hamid.
Thank you, Mark. All right, thanks for being here today. We are going to talk about Kinesis at Lyft, basically our experience with Kinesis as a streaming technology at Lyft. Yeah, Mark already introduced me, but my name is Hafiz Hamid. I'm the oldest engineer on streaming team at Lyft. Not in terms of age, but in terms of longevity of my time here. Yeah, I've been here for about 2.5 years, and the company was 600 people when I joined, and now I think we are 3,500. So yeah, I think this is Mark already mentioned, so I'm going to skip this. Okay, so the agenda of our talk is I'll start with an overview of streaming at Lyft, what we mean by this, and the use cases and stuff, and then we'll have an overview of Kinesis, a quick overview for people who are not familiar with Kinesis, who have never used it, and then Lyft's streaming architecture, and then we'll talk about we'll do a quick review of Kinesis as a streaming technology, the lessons learned, best practices, and yeah. So event streaming at Lyft. Right. What are events? So anything which happens is an event. So they include user interactions when users interact with the Lyft mobile devices. Any interaction is an event. We record it as an event. Examples are pin move, ride requested, ride accepted, and driver rating, and all these. Every interaction basically is an event. And then the API interactions. For example, every time an API is called, that is an event. For example, location updated, right? The driver or passenger apps, when they send locations to the server, they constitute events. So, and then the developer events. You being a developer, you can just you can emit any sort of events which could be useful for anything. And then networking logs is another example. CDCs, change data captures, the change records from our operational databases, MongoDB, DynamoDB. I mean, they constitute events as well. And all of these events are ingested into the event streams. So yeah, some use cases quickly. Analytics is the top use case. All BI and reporting is based on these events. These events go into the data warehouse, Hive, Presto, Redshift, Druid, Elasticsearch. I mean, they get indexed into all these systems. And then data science is a big use, right? We have ETA models based on event data. We have localized prime time or pricing models. We have fraud prediction models based on these events. And then the third one is event-driven microservices. We have a pretty nice microservices-based architecture for our services, and a lot of these services are reactive services. Basically, when an event happens, they want to respond to these events, right? For example, an example is driver onboarding workflows. When a new driver is added to the system, right, a service might want to respond to it. When the status changes, like for example, the background passes for a user, that might be an event. Somebody might want to respond to it. And driver loyalty, reward workflows, ad tech workflows, and then passenger notifications. So okay, so a little bit about scale. We stream around 80 billion events every day, which is around 70 terabytes of data. And so at peak, we ingest around 1.2 million events per second. And we have around 125 consumers for this, for our event streams. Right. So now let's do a quick overview of Kinesis before we talk about our experience with it. So Kinesis, for those who don't know, it's a fully managed service for real-time big data ingestion and processing by AWS. It's good for fast, high-throughput data ingestion. And it provides at least once delivery with KCL. KCL, we'll talk about KCL a little bit. KCL stands for Kinesis Client Library, Kinesis Consumer Library. And then it provides ordering guarantees within a partition key. We'll talk more about it. So at a high level, this is how it works. You capture, the developer code, your code captures and sends data to Kinesis data streams, and then Kinesis data streams ingested, and then you have your processing tier. You can choose between a bevy of processing tools. It could be, for example, Kinesis Data Analytics, Spark on EMR, your custom code on EC2, or Lambda, KCL, and then those applications they produce an output. And then some key Kinesis concepts. So streams. What is a stream? Streams are just named event streams of data, right? You basically you want to produce some data. You just provide a name, and you just provide a retention and you provide the number of shards, right? And then you can create a stream. Basically, I would So this is how easy it is, because it's a managed service, fully managed, right? This is how easy it is to create a stream. Right? Just provide a name, my demo stream, and then you specify the number of shards. I have 32 shards in this case, and you click create Kinesis stream, and boom, your stream is created in the cloud, and you can start writing data to it. You can start putting data to it. So, Shards. Shards is the base throughput unit for Kinesis. Every stream would consist of one or more shards. You can probably compare it to partitions in the Kafka world, and stream probably can be compared to topics, right? So coming back to shards, you scale streams by adding or removing shards, right? Each shard has a certain fixed max capacity. So each shard can ingest up to 1,000 records per second, up to 1 MB per second data rate, and on the consumer side, each shard can support up to 5 reads per second, up to 2 MB per second data rate, right? So I highlighted this 5, right? You might be wondering why the ingest is 1,000 records per second, and why the reading is only 5 reads per second, right? So just to remember that these are batched reads, right? So this is like a very interesting and important limitation of Kinesis. We'll talk more about this. So and partition key. It's an identifier used for ordered delivery and partitioning of data across the shards. You can pick a key as partition key, right? For example, in Lyft's case, if we want, we can pick the user ID as the partition, right? Picking that as a partition, it will ensure that all the records for that particular user, it would go to a specific only to a specific stream, right? And then it provides co-location of data, and when that data is processed, it would show up in an orderly fashion, and it would show up at the same processor. So that's the use of a partition key. And then sequence number. Every record which gets written to Kinesis, it has the AWS assigns it a unique sequence number, and basically these sequence numbers they are also ordered, and they are used to they are used to checkpoint on the consumer end, right, as well. So. And then the shard iterator age. This is from a monitoring perspective, this is an important metric which you have to monitor. It's basically the age of the last record returned by the get records API, right? And when you're if when the consumers are caught up. When the consumers are fully caught up, the iterator age would stay at 0, right? But if you start lagging behind, then your iterator age will start building up, right? It will start going up. I'll show you a graph on this later. A value, as I said, a value of 0 means consumer is completely caught up. And then KPL, Kinesis Producer Library. This is a library to use to produce records or events in an asynchronous manner. We don't use it here at Lyft, but the future slides will cover why we don't use it. And KCL is Kinesis Consumer Library. This is what we use. So yeah, and okay, so quickly, just to. I stole this slide from AWS Reinvent slide deck. So this is how we put data into Kinesis. We have bunch of producers here, right, which could be multiple applications or multiple instances, right? And then here is a stream, on the right, and this stream consists of multiple shards, right? And then when the producer is producing, they pick a partition key, and based on that partition key, it would Kinesis would determine which shard this record would go to, and that's how data gets written. And then getting data out of Kinesis, as I mentioned, there are you could use anything to process data, but here in this context, we are going to talk about KCL, Kinesis Consumer Library, because that's the most popular one, and we use it here at Lyft. And KCL, basically Kinesis Client Library, it's meant for fault tolerance, and it ensures at least once delivery, and it takes care of coordination between multiple workers, and it makes sure that all the shards would have workers assigned to them, and it takes care of leasing and checkpointing and basically all these things. And it provides all that scaffolding, and when you are writing a KCL app as a developer, all you have to do is you have to write the innermost loop. Basically, you just write a function, and that function gets a list of records, and then you can add in your code how to process these records. Okay, so in the KCL model here is you're going to have when you're doing it at scale, your Kinesis stream might be big, and you might need multiple instances, multiple machines to process it. And in this case, as we can see, there are there are multiple KCL workers on every instance, which are processes, and and each process has a shard assigned to it. Basically, each process, when it comes up, it has to acquire a lease for a shard, and then it start processing data for that shard, basically. And you can have multiple shards per instance. So, okay, so little bit about Kinesis Firehose. Kinesis Firehose. So far, what we have talked about, that's a Kinesis. That was about Kinesis streams. But there is another sister service in the Amazon ecosystem, which is called Firehose, and this one is my favorite, actually. And the nice thing about it is that it can a Firehose can automatically deliver data to various destinations, right? For example, it can automatically deliver data to S3, Redshift, Elasticsearch, DynamoDB, and also Splunk. and near real-time delivery, less than 60 seconds end-to-end propagation delay, and it provides buffering and compression. It provides automatic conversion to columnar formats like Parquet, ORC, and you can also do transformations on the real-time streaming data using AWS Lambda. And then another nice thing is that it scales automatically to match the throughput of your data, right? You don't even have to worry about, for Kinesis streams, you have to declare how many shards you want, right? And if in future your capacity increases, if you want more capacity, you will need to add more shards. But in this case, it is the number of shards is managed automatically by AWS. You don't have to you don't have to worry about it ever. And yeah, so. Yeah, this is what the flow looks like, and yeah, this is how you create a Firehose, right? This is AWS console. You provide a name and you provide like the destination. In this case, it's S3 and S3 bucket, the name of your S3 bucket and prefix, and your buffer conditions, right? For example, I want to buffer at 5 MB or every 300 seconds, what kind of compression I want to use, what kind of encryption I want to use, and then rest would be all automatic. You can just, you just create delivery stream, press that, and your delivery stream gets created in a minute or two, and then you can start producing data. It will start landing to your final destination, which could be S3 or Redshift or whatever. So, okay, so now let's talk about Lyft's streaming architecture. Yeah, there is a little bit of disclaimer here, before I talk about it. So this is our present production architecture, right? In 6 months from now, or about a year from now, it might be different, right? It might not look the same, right? So, this is which has been like, working well for us so far, and this is what it has evolved to. But we are doing some radical changes to the streaming architecture. Embracing Kafka and bringing in Kafka is one of those things. Yeah, but this is what we have so far, and it has been like, we'll talk about what is good about this and what is not so good about this. So yeah, so starting with the box on the top, it represents a Lyft microservice. As I said, we have a microservices-based architecture, and we have a collection of, bunch of maybe couple hundred or more microservices, and then the code which is running in the microservices, the developers can emit events, right? Using a logger, using an event logger, and which is a language-specific event logger, Python or Go or Java, whatever. And then, what you would see here is that we don't ingest events directly into Kinesis, right? Our ingestion is asynchronous. We basically, the logger, the events are first ingested into NSQ. NSQ is an in-memory. It's an in-memory buffering technology. It's open source, and it has disk back-off capability basically, and basically, think about it. If before ingesting into Kinesis, if you want to do some sort of buffering or batching, right, then you have to somehow buffer that. So at first stage we ingest into NSQ, and then there is an NSQ worker which runs as a sidecar process, right, on every machine. And NSQ then ingests data into Kinesis, right? So the reason we are doing this is that Kinesis has pretty high write latencies. The best write latency which we have been able to see is, I think it has been around 100 millisecond to 250 millisecond basically. So 100 millisecond is for a lot of things it's prohibitive to for us, I mean, it's like, if we do it synchronously, then that means, every request, it has to, you are adding 100 millisecond to every single request, right? So that makes it hard to ingest it synchronously. So, okay. So now the mobile apps also generate events, and they come to a gateway service, an HTTP endpoint, and then that HTTP endpoint has the same nomenclature as any microservice, and then the data gets ingested into a Kinesis stream, and then we have a KCL app here, which does the fan out, right? As I said, we have like 125 consumers, right? How are you going to publish this data to multiple consumers, right? So we have this. We have this app called Fanner, and it based on a routing and fan out config. It knows which events need to go where, right? For example, as a consumer, you want to specify that whenever a write gets dropped off, I want to get notified, right? You just go to that config, right, and provide your filters, or provide your subscription details, and then you will start getting that data. So as you can see here, Fanner publishes data to Fanner routes data to multiple different technologies. In some cases we send it to SQS. And from SQS it goes to another system here at Lyft, which is pretty heavily used. It's called Job Scheduler. Job Scheduler is basically a webhook delivery service, right? For example, if you have written your code behind HTTP interfaces, and you want to say that every time write gets dropped off or write gets requested or there is a pin move, I want a webhook to my service, right? So that is all, with Fanner and Job Scheduler, that would be all automatic. And then there are a bunch of our consumers are Kinesis Firehoses, right? And then a bunch of the other bunch of them is Kinesis Streams. So. And then, like for example, one of the consumers, our largest consumer here is this one, which is ETL ingest, right? And this guy, it subscribes to every single event, and then it uploads that data to S3 I think in Parquet format, and then from there. We have the whole ETL system which consumes this data and send it to Hive, Redshift, Presto, etc. So, and then for each one of the other streams, there are a bunch of consumers. I mean, these consumers could be Flink apps, or it could be KCL apps. So Flink is relatively new, but KCL we have been using it for a while. So. Okay, so in terms of size, we have around 80 production Kinesis streams and 10K total shards, and around 80 KCL apps and 40 firehoses. So okay, let's talk about the most important part of this talk. So here are the strengths of Kinesis in our experience, right? It's fully managed, it's elastic, pay only for what you use. Super high availability and reliability track record. We have been using it for 3 years, and we don't know of any major outages yet, like which lasted more than a few, more than maybe half an hour or so. Yeah, for puts actually. We have had some issues with gets a few times, but on the put side, we never had a significant outage. So yeah, it's relatively cheap. Honestly, we never have to even think about the cost of using Kinesis, compared to some of our other services, AWS services which we use. And so it has, like, if you guys are already using AWS, then Kinesis has a first-class integration with other AWS data sources, as I mentioned, Firehose, and it can automatically send data to Elasticsearch, S3, Redshift, etc. So some of the weaknesses, not truly real time. it's not, although they might claim it, but it's not really real time. It's a micro batching system. That's because now let's talk about. Let me remind you of that read throughput limits. You can only do 5 transactions per second, right? But these 5 transactions could be batched. So what that means is that when you do a get record, you can only do 5 get records per second, and it's going to send you a bunch of multiple records, and between 2 subsequent calls, you have to wait for at least 200 milliseconds. So you introduce those 200 milliseconds right there, and your puts were also like around 150 milliseconds, right? So you have already accumulated like 350 to 400 milliseconds in your latency. So, I mean, with Kinesis, you cannot, the best we have been able to get in terms of end-to-end latency is around 600 milliseconds. But in our case, if you see here, just because Kinesis does not provide it does not provide native fan out, so we had to build our own fan out. So that's why we had to make two round trips to Kinesis, right? So when you add, like, if one round trip is 600 milliseconds into 2, so you have 1200 milliseconds, which means sub-second latency is not possible. Yep. Okay. All right. So yeah. So weaknesses. The second one is, as I mentioned, it's not a true pub subsystem. So there is no built-in consumer fan out, right? Like, you cannot attach multiple consumers to a stream with only 5 transactions per second. And then the put latencies are relatively high, although AWS claims that it should be around 40. It should be around 40 milliseconds, but what we see here is that 100 to 200 milliseconds at P99. And then one of the issues which we saw when we started embracing more open source technologies, for example Apache Flink, we realized that Kinesis may not have good integration with these open source tools. So yeah, already talked about this. At P99, we get around 100 to 250 milliseconds for puts. There is a chart here. You see, this is for put response times during the last 1 month. You see that it has been this one is P99. It has been fluctuating. Sometimes it was around 100 milliseconds. Other times it was around 250 milliseconds. So not, but if you look at P95, that is pretty good. It's like 20 to 33 milliseconds. And end-to-end round trip is, as I said, the best we have been able to get is 600 milliseconds. Okay, so right. So you will see this very often if your KCL app is written badly. So what this means, I talked about, let me remind you of Iterator Range, which we talked about. Iterator Range means that how much you are falling behind, right? For example, in this case, you can see this is time. The x-axis is time, and the vertical axis is how much data is accumulated in the stream, which is waiting to be processed. So in this case, you might spin off your KCL app, and you might start processing data, but then let's say there might be a problem in your checkpointing logic, and then you might realize that, I was not checkpointing, and now when you restart the app, you realize that I have like a whole day of data to reprocess. Basically, I'll refer to this chart when I talk about the next slide. So some best practices. So when using Kinesis, choose a high cardinality partition key to avoid hot shards. Hot shards problems could be very painful. So random would be best. We use UUID4, which essentially is supposed to be random, and we hardly ever had an issue had this issue. So another one is configure KCL app to use all CPU cores, right? This is the #1 mistake which I have seen. For sometimes, when people write KCL apps, their code is single-threaded, but they are running it on machines which have like multiple CPU cores, and you are not like you provision as many instances as the number of shards, and now basically what happens is that one CPU core is going to be fully saturated, but all others, they are sitting idle, right? And when you're looking at CPU charts, it might look like, for example, on a 4-core machine, right? It might look like CPU utilization is only 25%, but it's actually 100% because your app, your code cannot use more than 25%, right? So it is important to take care of this in order to make auto scaling work. So another one is don't let your compute become the bottleneck. So this is a very important one, and we were doing it wrong for a very long time. And we were like blaming Kinesis, right? We were considering it as a weakness of Kinesis, but we realized that we are doing it wrong. Because we use Python here, most of our KCL apps, they are Python, and they were like, when the code was written, it was single-threaded. What that means is, basically, a single shard cannot leverage more than one CPU cores, right? So, and then your speed, the speed, the throughput of your app, it is limited by how much a single CPU core can process, right? So then basically the point here is that when you're writing code, write parallel KCL consumer code and leverage all the CPU cores. That way the bottleneck would not be in your compute, but the bottleneck would be in your read throughput, how fast you are able to read data rather than how fast you are able to process it. And that it will let you provision and scale Kinesis shards independent of compute. So the next one is be careful with your checkpoint. As I mentioned before, if you're going to run into trouble if you're not checkpointing how much you have processed, right? Because if your app restarts or or in terms of errors, right, you might be starting from the beginning of the stream. So another one is don't forget to monitor shard level metrics, right? A lot of issues they won't get exposed when you look at the overall metrics. Basically, you have to. This is not the default setting. You have to pay extra to get shard level metrics, and don't try to attach multiple consumers to a stream. With such a low read TPS, it's just not going to work. So plan for your peak events in advance. Like, for example, here at Lyft, our peak events are Halloween and New Year, right? So, and we have to because the thing is that scaling out a stream, it's a manual process, right? You have to basically provision it in advance and make sure that make sure that when the peak event is happening and you're getting twice or 3 times as much traffic, your applications would be able to stay caught up, right? And otherwise, things may catch you by surprise. And the thing is that since shards are immutable, even if you increase the number of shards, before the new shards are utilized, it would have to flush out the existing ones, right? So don't forget to reprovision DynamoDB IOPS after you reshard, right? This is another mistake which we have made at times because KCL uses a DynamoDB table for checkpointing, right? And basically it constantly talks to this DynamoDB table, and if you don't provision if you forget about it, you're going to run into trouble. So yeah, I'll just go through this quickly. I have just told. So. Our top pain points, is no hot restarts. When we deploy changes, when we do deploys and do service restarts, sometimes we see large spikes in latency. And because at startup the KCL needs some time for shards to get distributed across the workers and stuff, and then. High put latency is already talked about it, and high propagation delay, lack of native pub sub, we talked about it. Stream resizing is manual, although recently AWS rolled out auto scaling for Kinesis, but we haven't used it yet. Some of the features we haven't used: auto scaling, KPL. We have not used KPL because what I mentioned, what we have built for asynchronous ingestion, that is very similar to KPL already, so we don't have to do it. So Kinesis Analytics, this is streaming SQL on Kinesis data, I haven't used it, and replicated stream. So, okay, this is the last one. When is it a good fit? So when you want best effort durability, say 5 nines is good enough, Kinesis is a good fit. If sub-second end-to-end latency is okay for you, then Kinesis, then it's good. And then when you are already big on AWS in general, and you don't want to manage Kafka operations, you don't have the resources, or you don't have the right people, right? You're a startup, right? And you want to build something quickly. You prefer elasticity and pay per use policy. So yeah, that was all about it. And just a reminder that Lyft is hiring. Reach out to us if you are interested. And thank you very much. Any questions?
How do you manage it? Do you have like a schema registry solution, like a Kinesis, or how are you managing all these streams of data?
Okay, so yeah, this is sort of okay. So the question is that how we manage schema registry, right? So yeah, this is a little bit embarrassing actually. We don't have a first class schema schema registry thing. We basically our payload is just JSON objects, and for IDLs, for definitions, we use protobuf, right? But that protobuf is used just for declaring the types, but not as a wire format. But we are moving towards using protobuf as the protobuf as a wire format as well. We are making progress on that.
So you're going to standardize on one particular format, basically, for streams, right?
Sorry?
So you're moving to a direction where you're going to standardize your all streams in one a format that supports, for example, schema evolution, like a protobuf or Avro or some kind of thing, right?
Yes. Yeah. Any other question? We don't. Can we take one more?
Okay, sorry.
Okay. All right.
Yeah.
All right. Thank you, guys.
Thank you.